Katarina says to Valdemar, think of an integer, double it, square a result, add 24, subtract the number you first thought of, multiplied by 20, and now you are certain that your number is at least 0. Let's take a look at this question. Let's divide it into steps. And let's divide into steps what Katarina says to Valdemar. She starts with think of an integer. So I'll just first number the steps. Sorry, I'll just write it more neatly. So first instruction, second, third, fourth, fifth, and now I have certain results. So let's translate this. Let's translate sentences or statements 1 to 5 in the language of maths. So think of an integer. So let's say I call my integer x. In Swedish, we use like the whole numbers, hela talen. It's labeled by capital Z. So this is an integer. It means that it's neither like 0.5, 0.7, it's like the whole number. In the second step, Katarina asks Valdemar to double our integer. 3, square your result. So square the number we got in the previous step. So 2x and the whole thing squared. We can simplify it right away to 4x squared. In the fourth step, add 24, so 4x squared plus 24. And in the final step, she asks him to subtract the number you first or originally thought. So again, we start with the number from the previous step, and now subtract the number you thought of, that it's just x, multiplied by 20. So minus 20x. And how do we know? What can we say about these numbers? X can be anything. And since I can have different values of x in different integers, it can be -7. Yeah, x can be -7, or it can be, I don't know, 1. It can be 50. It will construct or model the function so that and the domain of this function will be all integers. So let's write down this as a function. F of x is equal to 4x squared plus 24 minus 20x. The reason why I'm writing this as a function is that if you give me your original number, the number you are thinking of, and you want to get the result, you would just plug in the number here instead of x, and you would get the output. So x would be your input, output. Remember the function machine. And think about what this function looks like. So this is the important function we are going to be studying, and we want to see where its vertex is so that we can graph this function. We can either find the zeros first or directly the vertex. I will probably start, I would find the zeros normally. That's my way to go, but I'll try to find the vertex first. Why not? 4x squared. If I rewrite this function in the like a standard order where I have the quadratic coefficient first, linear plus 24, I can use the formula for finding the vertex, that the x-coordinate of the vertex is -b over 2a. Yeah, what is a? A is 4, B is -20, C is 24. Yeah, we will derive this formula. We can derive this formula, for example, from completing the square. The reason why I'm not using this formula that much is I'm not good at remembering things, but this is very useful. And now let's evaluate. So it's -20 over 2 times 4. That's equal to 20 over 8, which if we divide by 4, so we get 5 over 2, so 5 halves, or just 2.5. So now I know where the the x-coordinate of the vertex. I will find the zeros. Yeah, this is where I would normally start. In order to find zeros, I need to solve the quadratic equation. This is equal to 0. And 4, instead of dividing by 4, I will keep the 4. I will just factor it out. Is equal to 0. I will now factorize x squared minus 5x plus 6. Remember the sum product rule. So this is x minus 2x minus 3 is equal to 0. So the zeros are x is equal to 2 and x is equal to 3. And yeah, if we started with the zeros, the x-coordinate of the vertex sits in between 2 and 3, so it's 2.5. I just wanted to remind you of that formula because with optimization problems you can use this formula. But yeah, with this question I think it's a better idea to start with the zeros and then finding the x-coordinate of the vertex as the midpoint. I will sketch the function here very roughly. So I know 1, 2, 3, 2 and 3, and the value, this is my vertex. What is the value of the function in the vertex? So 2.5. I will use, the other reason why I factored out the 4 is because I can now easily evaluate the value in 2.5. So 2.5 minus 2 is just 0.5. 2.5 minus 3 is negative 0.5. So this gives me negative 4 times negative 0.25, and that's negative 1. So the value, or the minimum point for this function, is at negative 1. This is the vertex. We'll use some color so that it's clearly visible. Yeah, and if I were to graph or sketch the graph of this function, now again, wish me luck so that I make it as neat as possible. Yeah, good. And why is this graph helpful? Why is this graph pretty much the answer? We know that x must be an integer. So if we are integer and then we get the number which is at least 0. So if we take any x value here, my output is always positive. If I take 2, I get a 0. Can I take any value between 2 and 3? Yeah, no, there is no integer between 2 and 3. So in this part, there are no integers between 2 and 3. I can take 3 then again, but then it's 0, and then 3 and the bigger values, I again end up with positive output. So that's why I know that my number will always be at least a 0. And I'll just repeat. Yeah, I started with finding the x coordinate of the vertex, but that was mainly to remind you of this formula. But I would start here by finding the zeros of the function.